What up, YouTube? This is Banjo3 here. Oh my lord. Okay, so there is this YouTube channel, right? And I will write its name right here, and I will probably post a link in the description. Numberphile. It's a bunch of mathematicians who spend their time looking at number patterns and stuff, and I thought it was really cool. So I looked at their videos and I saw every single one that they had posted on YouTube. And there's one that really made me think. So 16 is a perfect square. Alright? 16 is a perfect square. What does that mean? It is a square of a square. So 2 squared is a square 4. 4 squared 16, right? Easy math. That didn't really fascinate me. What did fascinate me is what they said afterward. 16 is the only number where this happens. X to the power of y is equal to y to the power of x as long as x does not equal y. Bang. I have only found 2 numbers where this is true, and where this line is true, the first line. There's only one number where both of these lines come true, and that ends up being 2, which, if you plug into the formula, will equal 16. I went through a long derivation to try to prove this wrong, and sadly, I proved that it was right, that there is no other number other than 16, and I will show you the derivation now. Alright. I hate this freaking chair. It doesn't swivel like it's supposed to. Anyway, so you got x to the y is equal to y to the x. Right? Alright. So now you do your simple log functions. You say log of x, y. Oh, I'm sorry. Log base a of x to the y is equal to log base a of y to the x. Alright? Now, using your simple log functions, you're able to put this exponent on the top here into the front. So, y of log base a of x is equal to x log base a of y. Now, with that, you are able to put all the non-logs on one side and all the logs on the other side. So y over x is equal to log base a of y over log base a of x. Simple as that. And there is a log property for that. Don't exactly know the name of it, but you can simplify that to become log base x of y. Just take this bottom number, put it as the base, and put the top number and put it as the regular self, and it becomes that. Now, how does this help you at all? It changes the formula, because if you put it in exponential form, by the way, that kind of like a y, sorry about that. Anyway, right here, this formula right here, x to the power of y over x is equal to y. This is going to be one of your base formulas for finding out how to do that. As you'll see right behind me, right there, is the rest of my work. I had to erase the first part of it because I memorized the derivation, but I did not memorize the work. Once you get here, though, the x to the power of y over x equals y, you can do what I just did back there, which was really annoying. Wouldn't you find it annoying if you found out that all the work you just did was just a proof to show that you were wrong? Anyway, so I don't know whether I want to just go up there and show you what I did or come up here. Actually, I think I'm going to go back there. This will be part 1 of why no one should listen to me. Okay, we'll have a sequel later. Alright, let's just bring the board up to us. That'd be a lot easier for you guys, not for me. Anyway, so you start out with this equation right here, right? I am pointing to the right side. Right? There we go, that lag on that computer. X is equal to y over x is equal to y. Now you have 3 options. 1, you make y equal to a plus x plus a. 2, you make it y is equal to x times a. 3, y is equal to x to the power of a. And you are allowed to do this. Nothing wrong with that, as long as you're consistent throughout your work. Alright, so when you do one side, you have to do the other. So right here, I tried the first scenario, which is why I have a 1. And that didn't look really nice. So I crossed it out, WTF mate, you know. So I went down to this section. Just ignore the number 3 for now. I'll get to that in a second. Okay, now as you'll see for the 2 part, if this my computer stops lagging, you'll see x to the x times a over x is equal to xa. And then you will see that you can just cancel the x's on the exponent to make it x to the power of a is equal to xa. Now from there you divide by x, and your exponent should just go down by 1, equaling x, a to the minus 1 is equal to a. Which, if you see the arrow pointing in the middle of the whole thing, is the exact same thing as if you would do it the other way, x to the power of x to the a over x is equal to x to the a. Because what you do is you divide. I have no place for my hand. I wish I had a pointer stick right now. My big stick won't work. I guess I'll have to do. Oh wait, I found something I can use if I can get off my leg. Ta-da! Okay. So right here, you just divide by x, right? And then you'll get x to the power of a minus 1. And you can set those two equal to each other because their bases are equal. So x to the a minus 1 is equal to a, which is what you came up with the second equation. Oh, the second substitution that you did, which is why I drew an arrow toward it. Now, I just plugged in the values for a at the spot, and I saw which ones would work and what's the pattern here. So for the first one, I got a is equal to a because x to the 0 is still going to be 0 no matter what you do, unless x is 0. So it's a. For the second one, I got x is equal to 2. For the third one, I got x is equal to the square root of 3. Fourth one, I got x is equal to the cube root of 4. Same with 5, and the list can go on forever. What I found for a basic formula for all of this is that x will equal this formula every time. This is what x will equal. And I'm no genius or whatever, but hopefully someone who's a god at something, I don't know, a genius perhaps, will figure out something that goes into this equation, alright, but equals a whole number. That's the trick. Like, I can get this to equal the square root easily. This can be the square root of 3, and that will work perfectly in your equation. Unfortunately, I'm pretty sure you're only allowed to use whole numbers and integers and positive numbers, because you probably couldn't use a negative number anyway. So positive integers, please, and x cannot equal y. So in this one, you can see that you can get 1 is equal to x, 2 is equal to x, 3 is equal to, square root of 3 is equal to x, and so on. Can't use this or anything beyond it because they all equal square roots. And unless you can find a square root where where this equation right here is equal to a whole number. Good luck with that, by the way. Unless you can find that, the only two legitimate ones are 1 and 2. And you can't use 1 because, as I don't remember if I mentioned earlier or whether I did in the few tries that I actually tried doing this because I messed up a few times. X cannot equal y. So x, sorry about that. Let me erase that. 1 to the power of 1 over 1 is equal to 1. That is true. 1 is equal to 1. Check QED. Until you read the restrictions where x cannot equal y. Because once you get to that, you will realize, oh, GG, x was 1, y was 1. But when you plug in 2, you will get 2 to the power of whatever this is, we'll say a over 2 is equal to some a value, and a will end up being 4. So 2 to the power of 4 over 2 is equal to 4, which 2 to the power of 2 is equal to 4. 4 is equal to 4. Check QED. For you, those of you who don't know what QED stands for, that is just, I think it's Latin or Greek, can't remember exactly which one, for quod era demonstrum, or demonstrat, something like that. Google it, not hard. Though I can't speak. I have speech stuff problems, as you can just tell from there. Anyway, so for all you mathematicians out there, if you can find a number where, again, n minus 1, the n minus 1 term, or whatever, of n is equal to a whole number. If you can find where that is equal to a whole number, you will, other than 2, you will find, and you find that, please, like, tell the world and claim it for your own, because I have yet to find out a number where that works other than 2 and 1. And 1 is not allowed, because 1 would end up being itself. This is Banjo-Kazoo-Fan3 here, replying to Numberphile, saying, I don't know whether I proved your theory or not, but you just made me use up like 2-3 hours of my life trying to figure this out, and I just ended up proving you guys right. I have no idea how crappy I feel. Anyway, thanks for you guys for giving me an idea today. That was really fun. I'm not a mathematician, but I always thought math was fun. And you guys just make it amazing. This has been Banjo-Kazoo-Fan3 saying peace and have fun finding out the number or just enjoying this.